So let us see how to find the nature, index and signature of the quadratic form. So index, the number of a positive term in its canonical form is called the index of the quadratic form. So you know how to convert from the quadratic form to canonical form. So after converting from the quadratic form to canonical form, you will be getting the diagonal matrix. So in the diagonal matrix, we have to find out the diagonal entries, how many positive terms are there, and that is called the index of the quadratic form. Then signature, the difference of the positive terms and the negative terms on the canonical form is called the signature. Then coming to the nature of the quadratic form. So you know the real quadratic form x dash ax in a variable, it is said to be positive definite if all the eigenvalues of the given matrix are positive or greater than 0. And it is said to be negative definite if all the eigenvalues of A are less than 0. That is, all the eigenvalues are negative. Then positive semi-definite if all the eigenvalues of A are greater than or equal to 0 and at least one eigenvalue is equal to 0. Then it is said to be negative semi-definite if all the eigenvalues of A are less than or equal to 0 and at least one eigenvalue equal to 0. Then the last case, it is said to be indefinite. Indefinite if some of the eigenvalues of A are positive. It is said to be indefinite if some of the eigenvalues of A are positive and some of the eigenvalues of A are positive and others are negative. So keeping this in mind, now let us find out the nature. Let us see a problem, how to find the nature, index and signature of the quadratic form 2x1 x2 plus 2x1 x3 minus 2x2 x3. Okay, so let us see how to find the nature, index and signature of the quadratic form. So given that the quadratic form is 2x1 x2 plus 2x1 x3 minus 2x2 x3. So the first step, let us write down the matrix of the quadratic form. So the matrix of the quadratic form is A. So you know the procedure to find out the matrix. So here there is no diagonal elements because there is no x1 square, x2 square and x3 square and therefore the diagonal elements are 0 here. Because the coefficient of x1 square, x2 square, x3 square are missing here. So the whatever is missing is taken to be 0. And then here it is x1, x2, the coefficient of 1 by 2 of the coefficient of x1, x2. So therefore it is 1. So 1 by 2 of a coefficient of x1, x2 is nothing but a12 and it is same as a21. And 1 by 2 coefficient of x1, x3 is a13. So dividing the coefficient of x1, x3 by 2, you will be getting 1. a13 is 1. So a31 is also equal to 1. And the coefficient of x2, x3 is nothing but minus 2. So therefore the entry a23 is minus 2 by 2 and therefore it is minus 1. a23 is same as a32. So this is the matrix of the quadratic form. And you know how to find out the eigenvalues. So the characteristic equation of the matrix is lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. So in the previous lecture, we have seen how to find S1, S2, S3. Now finding S1, S2, S3 as in the previous, we get the characteristic equation as a lambda q minus, actually here S1 is equal to 0 because all the diagonal elements are 0 here. S1 is equal to 0 and S2 is equal to minus 3. S3 is equal to determinant value. So determinant value is equal to minus 2. And therefore the equation becomes lambda cube minus S2 is minus 3, therefore minus 3 lambda, and S3 is equal to minus 2, and therefore you are getting 2 is equal to 0. And solving this, we get solving the characteristic equation, we get lambda is equal to 1, 1, minus 2 as the eigenvalues. So here you can see there are two positive, out of three eigenvalues, two are positive eigenvalues and only one negative eigenvalues. And therefore now we can write the nature, index and signature. So here two of the eigenvalues are positive. Two of the eigenvalues are positive and one eigenvalue is negative. So according to the rule, we can see the given quadratic form is indefinite because some of the eigenvalues of A are positive and others are negative. Therefore, the nature is indefinite. And coming to the index and signature, the index is nothing but the number of positive terms in the canonical form. So the number of the canonical form is what we know that D is nothing but the diagonal matrix which contains the eigenvalues as the diagonal elements. So the number of positive terms, the positive terms in the canonical form. So canonical form is what we know the eigenvalues are 1, 1, minus 2. So other rest of the elements are 0. So the number of positive terms is 2. Therefore, index is equal to 2. Then signature. Signature, the difference between positive terms and negative terms. Positive terms and negative terms in the canonical form. The difference between the positive terms and the negative terms in the canonical form. So number of positive terms is equal to 2. In the canonical form in the above D, you can see number of positive term is equal to 2. Negative term is equal to 1. And therefore, signature is equal to the difference. So the difference between the positive terms and the negative terms, and therefore it is equal to 1. Thank you. So we'll see, continue in the next lecture.